Hi Year 12. This is the solutions to the 2020 Extension 1 Maths HSC Exam. In this video we're going to look at the multiple choice questions. Question 1. Which diagram best represents the solution set of x squared minus 2x minus 3 is greater than or equal to 0? So we've got to start by factorising. So we're going to have x and x, 3 and 1. We want the bigger term to be negative, so negative 3x plus 1. So our zeros are going to be negative 1 and 3, so that cuts out b and d. Let's draw a quick diagram. Negative 1 and 3. Here's the parabola. We want to know when it's greater than or equal to 0, which is here and here. So we want it to point out, and the answer will be A. Question 2. Given f of x is equal to 1 plus root x, what are the domain and range of the inverse function of f? So remember, if we work out domain and range of f of x, then for the inverse function we just switch these around. Alright, so let's start off with f of x. Recall that the domain is going to be affected by this. We can only have positive values for x, or 0. So x is going to be greater than or equal to 0. The range, this is a positive number, plus 1, means that y is going to be greater than or equal to 1. Now for our inverse function, we're going to switch these around. In other words, x will be greater than or equal to 1, and y will be greater than or equal to 0. And so our answer is C. Question 3. Which of the following is an antiderivative of 1 on 4x squared plus 1? Alright, so using our formula, we've got 1 over, I'm just going to turn it around, 1 plus 2x all squared dx. So f of x, in terms of our formula, is going to be equal to 2x, and f dashed of x is equal to 2. So we want a 2 on top, so I'm going to adjust by putting a half at the front. So it's equal to a half times, now I'm following this, 1 over a is 1, inverse tan, f of x is 2x over a plus c. Tidying it up, we have a half inverse tan of 2x plus c, which one is that? D. Question 4. Maria starts at the origin and works along all of the vector. All of the vector, that's a weird way of writing it. 2i plus 3j, and then walks along all of the vector 3i minus 2j, and finally along all of the vector 4i plus minus 3j. How far from the origin is she? Alright, so we want to add these vectors together. So 2i plus 3j plus 3i minus 2j plus 4i minus 3j, which will give me 2 and 3 is 5, and 4 is 9i, and then 3 minus 2 is 1, minus 3 is minus 2j. And now we want the magnitude of that vector, which will be equal to the square root of 9 squared plus negative 2 all squared, which is equal to the square root of 85. Our answer is B. Question 5. A monic polynomial p of x of degree 4 has one repeated 0 of multiplicity 2 and is divisible by x squared plus x plus 1. Which of the following could be a graph of p of x? So let's say that the repeated 0 of multiplicity 2 happens at x is equal to k. In other words, we've got x minus k all squared as a factor. And here's the other factor. Now, if you expand all of that out, what we're going to end up with is, I'll just do this bit at the beginning actually, minus 2kx plus k squared multiplied by x squared plus x plus 1. Our constant term is going to be k squared times 1, which is positive. So having a look at the y-intercept of all of these options, A is going to be out because we have a negative y-intercept. Now furthermore, this one here, if we just have a look at that, x squared plus x plus 1, the discriminant here is b squared minus 4 times a times c, which is negative 3. So there are no other roots other than the repeated 0 of multiplicity 2. So this one here has got 2 other roots, so it's out. This one here has 2 other roots, so it's out. So our answer is C. Question 6. The vectors A and B are shown. Which diagram below shows the vector V equals A minus B? Probably the easiest way to do this is to turn this around so it's vector addition rather than subtraction. In other words, V plus B is equal to A. So we're looking for something like this. I'm just drawing something random. So V plus B is equal to A. So let's have a look here. V plus B, A, it's not A. V plus B, it's not B. V plus B, that's going the wrong way, isn't it? So it's not C, hopefully it is D. V plus B equals A, yes it is D. Question 7. Which of the following best represents the direction field for the differential equation dy dx is equal to negative x on 4y? So this is really just trial and error, isn't it? Let's try and pick a unique-ish point. Maybe we will try 0, 1. So x is equal to 0, y is equal to 1. So in this case, substituting that in, we're going to get negative 0 on 4. So it's 0 there. So it could be A. It cannot be B. It cannot be C. Wow, it cannot be D. The answer is A. Question 8. Out of 10 contestants, 6 are to be selected for the final round of a competition. 4 of those 6 will be placed first, second, third, and fourth. In how many ways can this process be carried out? All right, let's start here. 10 contestants, 6 are to be selected, so order is not important. And then 4 of those 6 will be placed in order. So we want, out of the 6, we want to place 4 of them. Now, using our formulas, we have 10 factorial over 6 factorial, 4 factorial. And then 6p4 will be 6 factorial over 2 factorial. So that cancels. And we're left with 10 factorial on 4 factorial, 2 factorial, which is C. Question 9. The projection of the vector 6, 7 onto the line y equals 2x is equal to 4, 8. The point 6, 7 is reflected in the line y equals 2x to a point A. What is the position vector of the point A? Now this is a really good question because if you try and do this with projection formulas, you're going to be there a while. It's much easier to do through coordinate geometry. So it's a good reminder that if you get stuck with vector questions, try and go back into coordinate geometry because you might be able to do it much easier. So let's start by drawing y is equal to 2x. It looks like that. So in other words, we've got the point 1, 2 here. And I didn't really think about that, did I? The projection of the vector 6, 7. So 6, 7, let's go 2, 4, 6. So this here will be 4. That will be 8. So 6, 7 is here. This point 6, 7 is reflected in the line y equals 2x to a point A. What is the position of point A? So go up there. We know that that's going to be right angle. So this is the point 6, 7. So going across into there, we want the coordinates there. Now, we will just go through and see which one of these it is. 6, 12, that's out. 2, 9, possible. Negative 6, 7, out. Negative 2, 1, out. The answer is B. Question 10. The quantities P, Q, and R are connected by the related rates. K, L, and M are non-zero constants. Which of the following statements is true? All right, firstly, dr dt, well, that is less than or equal to 0, so R is decreasing. And then we've got dp dt is equal to a negative times a negative, which is a positive, so P is increasing. So it's not C and it's not D. And then here, that's back the front, isn't it? So let's change it around. dq dt is equal to 1 on m squared times dp dt. Now this is positive, m squared is positive, q is also increasing, so our answer is A. Okay, that's it for this video. In our next video, we're going to look at questions 11 and 12.